So this is ETP 2131 latex processing technology. So before starting, I will introduce myself also. I'm Asangi Ganurua, and I did my basic degree in chemistry from University of Peradeniya. I did chemistry special, and thereafter I joined with Uwavellasa University as a probationary lecturer, that is a junior lecturer. So in Uwavellasa University, I served there around 7 years. At that time, I completed my master degree. My master degree basically talking about splitting water with radiation. Okay, so it is basically for fuel type 1 to convert water, hydrogen into hydrogen fuel. Then after that, I joined Nagaoka University of Technology, Japan to do my PhD. I did my PhD in 2018, completed it in 2018. So in my PhD, basically it is in natural rubber latex and also in the field of fillers and nanomaterials. So I have basically completed all types of filler interactions and all. So you might be able to learn these ones mostly in your postgraduates, I think. So let's do latex processing technology with me. I will be continuing from the top where you take from raw rubber technology lecture series. So that is why I asked you all previously, what did you all do in raw rubber processing technology? Now, in the case of latex processing technology, we will be talking mainly about products that is produced from latex. So all these type of products that I have shown you here are manufactured based upon latex. So when the term latex comes into your mind, it would say it is natural rubber. Is that so? Latex, the word latex will always remind us the rubber tree and the milky sap coming from the rubber tree. Yes or no? Now, I'm doing an interactive lesson. So always, if you don't understand, you can interrupt me. You can talk with me. If anything unclear to you, you can talk. Now, I'm talking about the introduction. So just talk with me. You all have learned raw rubber. So under raw rubber, you have learned different processing of latex into different rubber raw materials. Okay, that is what you learn under raw rubber technology module. That is converting natural rubber latex into different rubber-based raw materials like sheet rubbers. What are the sheet rubbers that you have learned? So where are your mouths? Just unmute and talk. I could hear all of your nice voices in the introduction, but no answers when I talk. Otherwise, I will, yes. Just, who is this? Yes, Puta.
Excuse me, RS is sheet rubbers.
Yes, RSS. What else? Okay, Dilshri?
Crepe rubber.
Crepe rubber, yes.
TSR.
TSR. Then you have crepe. What type of crepe you have? You have sour crepe, brown crepe, then pale crepe. So there are so many rubber grades within the products that you have mentioned now. So now in the case of these sheet rubbers, we make them and you use them in dry rubber manufacturing processes. So mainly dry rubber means the solid rubber that you converted out of latex. But in the case of this module, we will be talking about natural rubber latex, which has been converted back into another form of latex. So what are the latex raw materials that you have learned in raw rubber manufacturing technology? What are the processes that you learned? If you don't answer me, I will put up the easier ones. Then you all go into harder ones. Huh? So what are the types of latex that you have learned? What are the latex? What is the main processing that you learned?
Centrifuge latex and the cream latex.
Okay, so you have learned centrifuge latex and cream latex. Now, in the case of these two, what is the most widely used raw material in rubber-based products in the market or in the industry today?
Centrifuge latex.
Yes, very good. So, you'll use centrifuge latex in order to make different types of latex-based products. Now, if I ask you, name 5 latex-based products, what do you think? How many you can write? Even if I ask you 5, how many do you think that exist in the world today? How many latex-based products? You might not believe me, it is more than 30,000. Okay, so if I ask you write 5, that means it is really easy. Now look at this picture and tell me 5 products. 5 products. Even when you look at this, you can name 5 products. You can tell me what are the latex-based products that you know.
Balloon.
What is it? Gloves?
Balloon.
Balloons?
Mattresses.
Yeah, mattresses. And this is a pillow here.
Toys. Gloves.
Yeah, gloves is there. What is this? Feeding bottle nipples, or you call rubber tits. What are they?
Toys.
Toys. These are casted toys. What are these? These are simple elastic threads. These are also known as latex threads. Okay. So under raw rubber manufacturing technology, what you have learned is how to collect your latex, how to collect it in the field, how to preserve it in the field. Then once you collect it, take it out into the factory, you collect it and how to process it. And I hope you all have learned by now how to do creaming and centrifugation process. So these things you all have done and you're awaiting for the exam to come. So now from this point onwards, I will be moving forward. But there are certain points, certain topics that I would go back and talk again. Okay? So what we basically talk is using centrifuge latex along with different manufacturing processes, and you could make different products. So this module will cover how to process this latex in a way that you can go for a product. But designing and manufacturing of latex will be done in the next semester as a separate module. So this module, we will be basically talking about how to process the latex and move towards production process. Understood? So different processing techniques, how to modify latex, how to process the latex so that you can produce a good out of this one. Okay. So now, as we talked before, I will briefly show you some natural rubber-based products. As you all told me, there are balloons. That is the simple first rubber product that you might understand that you are using. Other than that, you first use a rubber nipper. Then we have latex sheets. Okay, sheets. Then we have rubber gloves. So gloves also, there are so many different types. Depending on the use, you can have different types of gloves. And this is called extension bands or rubber thread band. This is used for exercising. Nowadays, many gyms use this thread band. Have you all used this one? More mainly boys, I suppose. Even girls, have you all used this thread band? Use color.
Yes, madam.
Okay. So now, this lady is sitting on a mat. What do you think this mat is? It is a latex-based yoga mat. Then we have rubber bands, casted toys, feeding bottle nipples, pacifier teats, foam mattress, foam pillows, foam shoe insoles, latex threads. So you have elastic bands, you have socks, you have crepe bandages, food wrapping, so many latex threads available. Then we have latex sponge. You have tubes, medical tubes, catheters, and many more. So these are some of the examples of natural rubber latex-based products. Other than natural rubber latex, there is another set of vast variety of products that is manufactured using synthetic latex. Now tell me some synthetic latex that you know. Lattices. දන්නේවා තියෙනවද? කෝ ඉතින් ටට්ටක් ගාලා උත්තර දුන්නොත් ටට්ටක් ගාලා ලෙක්චර් එක කරතයි කි. Now in the case of examination gloves, you have white color glove and also a very thin blue color one. Have you all seen this light dark blue or somewhat a blue thinner version of examination gloves? දැකලා තියෙනවද? lecture එකේදී නම් ඔළුව හොල්ලනවත් බවත් පෙනෙනවා. මට now I don't see all. So I just unmute and talk. Light blue color examination glove. ලෙඩ්ඩු බලන්න දාන gloves වල පාට මොනවාද? සුදු පාටයි, නිල් පාටයි. මම මේ අහන්නේ නිල් පාට එක දැකලා තියෙනවා. Any idea what this light blue glove made out of? That is nitrile. So there are many rubber based, that means synthetic rubber latex made out of petrochemicals. For example, XNBR in nitrile, SBR, NBR, and there are so many. PVC. So whatever the latex, if it is coming into latex stage, the property of the synthetic rubber will be same as natural rubber latex. We will call it as latex. So mainly all these polymer based products, we call it latex if it is in liquid form. We'll see what is a latex then, okay? So before moving on into the lecture series, I will give you the reference texts. These polymer lattices, Science and Technology, Volume 1, 2, and 3 by DC Blackley. You can download it from internet. It's available. Mostly I will be using volume 2 and 3. The ones that is available, only one book is not available in internet for free, but other two are available. Those two will have enough information for you for this module. Other than that one, we have polymer lattices and their applications by K.O. Clavett. And also I will be using ISO standards for rubber latex. All 5 are available in the internet. So you can easily download a copy and use it as this reference book. Understood? Other than that, I will be using 2 other books. Okay. You can. So this one. Science and Technology for Rubber. This is by James, Mark, Brooke Herman, and Michael Rowley. Okay, Science and Technology for Rubber. This book is also good, but that is, I don't see any reference book free of charge for this one. So better if you can download the first set, Polymer Lattices by DC Blackley. If anybody could download, please share it among the group, okay? Can you all do? අනේ තනියෙන් මට කම්පියුටර් එකට කතා කරන්න හරි අමාරුයි. Can you all do? Pasindu?
Yes, madam, we can.
Yeah, check the internet and get it done. If the lectures are and the module is completed under online mode, if exams are online, the assessment criteria might be changing. But if the assessment or the end semester exam is done physically, your assessment criteria will be mostly 60% out of in semester, 40% out of continuous assessments. Now this is the old version, that is 30-70 when it is done under total physical. Okay, so if it is exam is in online mode, you will be having 60% for continuous, and I will give you more assessments. And if the final assessment is physical, the end semester written paper will have 60%. Okay, make the correction here, 60% and 40%, and you will have quizzes, assignments. If the lecture mode converts into a physical one, you might get some presentations as well. So now you could see there are 3 types of assessments I have used. So you have 3 different levels of hardness, or time spending for different assessments will be different. So they will carry different weightages according to the difficulty and the time that you take to complete a single assessment. Okay, so based upon the effort you make, I will change the weightages. So that means if I have give you 3 assessments and you think you have completed one, I have 15 marks or something. 40 divided by 3. What is it? Here the around 13. So to get 40, how many do you need? 40% of out of 40 marks is 16. So if you want to get 16, if you think doing single assessment is enough, that is not the case. That is what I'm talking. Okay. Teruna neda? Yes. All the assessments. Right. Let's move. Quickly move. Otherwise, you will be in a problem with understanding. I'm stagnating. Now, before we talk about natural rubber, we have to talk about polymers, because natural rubber is a naturally occurring polymer. Now, when you do polymer, you did introduction to polymers and polymer technology. I hope you all know the definition of polymer by now. So polymer is, what is the definition of the polymer? Polymer is a macromolecule that is composed of different simple unit get together to form a one big chain. So these polymers either could be single repeat unit or 2 or 3 different repeat units. According to the repeat units, the polymers will change. Now, when you talk about polymers, it could be classified according to the behavior with rising temperature as thermosets, thermoplastics, and elastomers. So basically, natural rubber, you can consider it as a elastomer as well. Now, this graph shows extension with stress. We also call it stress strain graph. Now, this stress strain graph, you have this type of behavior for rubbery materials. For crystalline ones, you have a higher gradient. In the initial stage, you have a peak, and then again it will increase, but at this point it will start breaking down. This point you call it failing point or the breaking point. In the rubbery one, you have initial small gradient and a rapid increase until, in the lower extensions, you have a rapid increase of gradient and then move with slower gradient. So these are the basic mechanical properties of glassy, crystalline, and rubbery materials. So basically, polymers are going to be in rubbery type of material. In the case of natural rubber, in lower extension, it shows somewhat crystalline properties. After a small extension, and that will be rubbery. So that is one thing that you need to understand. Okay, this behavior of different polymers with extensions and stress, you will be learning for mechanical properties. That one I will not do it. Okay, so why do we need or important of learn natural rubber? As a raw material, what are the importance? Okay, you can see a good oil resistance, low gas permeability, improved rolling resistance, high strength, resilience, elasticity, resistance to abrasion, impact resistance, low cost, and also it has low efficient heat dissipation. And this makes it ideal for use of medical and other applications. That is why we learn natural rubber and we use natural rubber in the manufacturing processes. Okay, so as a small assignment, I need you to write some applications of natural rubber as dry rubber and latex in separate. Okay, first assignment for you. First question, write this question in your in a paper and then upload it to LMS. That is, what are the applications of natural rubber as dry rubber, as natural rubber latex? At least you have to write 5 applications per one. Can you do it? I will give small amount of marks for this one as well. 2 days is enough, right?
Excuse me, madam.
Yeah. Yeah, Puta.
Madam, පොඩක් ක්‍රියා මැදි ඇහුණා ලැබුණා ප්‍රශ්න කියද්දි.
කොයි හරියද බබා පුතා ලැගුණේ?
assignment එකගෙන කියද්දිම තමයි ලැබෙන්න ගත්තේ. මට
Hari. Hari puta, hari. Okay, no worries. Now, as I said, why do we use natural rubber as a polymer raw material is, I have already listed out what are the main outstanding properties of natural rubber. That is good oil resistance, good gas permeability, improved rolling resistance, high strength, resilience, elasticity, resistant to abrasion, impact resistance, low cost, and efficient heat dissipation. Okay. So because of this one, you have many medical and other applications. Now, as I ask you, I need 5 applications of natural rubber as dry rubber. And I need 5 applications of natural rubber as latex-based rubber. Okay, that means if the rubber product is manufactured using sheet rubbers, you can write it as dry rubber applications. If centrifuge latex is used as the raw material for a particular product, you can write it under latex-based products. Understood?
yes madam.
Okay, so that is the question number 1. Two days given, okay? Right. This one, I think Susanta sir did it. Propagation of rubber plants. Did he do? History of rubber, I think Susanta sir completed it. History of rubber, was it completed by Dr. Susanta, or do we need to talk?
Yes, madam.
Yeah, so we will move to propagation. Now, in the case of propagation, we will have different types of rubber plants based upon the way they are propagated. We can propagate natural rubber plants using seeds. These are called seedlings. Okay. The propagation of rubber plants could be done in 2 main ways. One is using seeds, and these are called seedlings. Now, the seedlings are very easier to propagate and they are cheap. However, in the case of seedling rubber plants, they are very big. Okay. Now, in the case of rubber plantations, several decades back, you could see the rubber plant is very big, rather than nowadays you have very small rubber plants in the plantations, very big. So you cannot even hold a rubber tree with your 2 arms stretched. Nowadays, very thin. But this bigger plant did not produce that much of latex that what we are producing today. Okay, seedlings mainly had this problem. They do not produce much rubber latex from 1 year. And also seedlings showed high variability of the yield and the quality within a year, or with the age it changes. So scientists or the agriculture people did many research and found that graft derived clones, okay, these are clones actually, graft derived clones will have higher yield And also the variability of the quality is consistent in the graft derived clones. So this is clones, that is why they are thin, they are not natural. So usually these are budded clones and they have uniform productivity throughout the year and throughout the lifetime until you deroot it and plant the new varieties. So mostly that is why we use cloned rubber derivatives. Okay, so there are two types of rubber plants propagating either in seedlings or they are derived from clones. So when you talk about natural rubber, the chemical structure is very important. I hope you all have learned this one again. This outstanding properties of natural rubber that, as I said before, you have high oil resistivity, high green strength, and there are many, many outstanding properties of natural rubber. Mainly, these outstanding properties are due to chemical structure of natural rubber. Okay. Now, the basic chemical structure of natural rubber is cis-1,4 polyisoprene. You should know how to draw the cis-1,4 polyisoprene if you are learning natural rubber and the polymer type of decrease. At least you should know how to write the chemical structure. Basically, I hope you all have learned about the isomerism of chemical structures. When you have a double bond, if the bulk groups are in the same side, you call it cis isomer. If the bulky groups are in two different sides, you call it trans isomer. In the case of natural rubber, you can see this is the first bulky group here. Okay, it is the same side as this one in every double bond. So that is why you called stereoregular polymers. Okay, because of this structure, these outstanding properties are arrived. This, how do we know that because of this structure, these properties are coming out? How do we know that one? As a technologist, you should know why this occurs. How do we say because of this structure, this outstanding properties are coming out? We take the other one. Okay. We take the trans version that is coming out of gutta percha. Okay, gutta percha is also a plant which produces milky sap, and this milky sap is mainly contain trans-1,4 polyisoprene. Now, when the scientists found, or they tap and take this milky sap, it is not tacky, it does not have this green strength. So the people found that this outstanding properties of natural rubber basically depend upon the basic chemical structure of natural rubber. Now, today, that concept is also not there because there are some other structural properties of natural rubber is found to be responsible for most of the outstanding properties, not only the basic chemical structure. So that one, when you go for higher studies, we will teach you what type of chemical variations, what type of structures that will contribute to outstanding properties of natural rubber. But basically, it is found that this cis isomer is the one that will give rise to most outstanding properties of natural rubber. Make a therunada. I think you all have learned this one under raw rubber when Susan sir was doing. තේරුම් නැත්තම් කියන්න. නැත්තම් ඉස්සරහට යන්න. Cis isomer එක කියන්නේ මේ ලොකු groups double bond එකකින් එක පැත්තේ තියෙනවා නම් cis isomer එකක් වෙනවා. ලොකු group එකක පැති දෙක තිබ්බොත් එක trans isomer එක වෙනවා. මේ තියෙන්නේ මෙන්න මේ double bond එක ගැන හිතුවොත් මේ තියෙන ලොකු group එක මේ තියෙන අනිත් ලොකු group එක ඒ දෙන්නම double bond එකේ එක පැත්තේ තියෙන්නේ. මේක හැම carbon double bond එකකටම මේකේ තියෙන සමානයි. ඒ හින්දා තමයි අපි කියන්නේ stereo regular කියලා. මේ වගේ structure එකක හින්දා තමයි natural rubber වල outstanding properties ඔක්කොම generate වෙලා තියෙන්නේ. That is why many synthetic polymers cannot compete with the structural or the properties of natural rubber. That is why still we don't completely what do you say, completely substitute natural rubber. We don't completely substitute natural rubber because the other polymers that people produce could not compete with the outstanding properties of natural rubber. Even though you add different properties and change this one, we need natural rubber for certain products to be manufactured. තේරුණාද? Okay. Now, in the case of, again, natural rubber, that is cis 1,4 polyisoprene latex, that is actually not produced only from Hevea brasiliensis tree, that is known as rubber tree. It is also produced in different other plant varieties, and nowadays, in mostly in developed countries, these substitutes are being highly researched so that they could use. One example is rubber dandelion. Rubber dandelion is a weed actually. This weed have a root. When the root is broken, it will produce cis 1,4 polyisoprene sap. You all can see this one. When you break the root of rubber dandelion, dandelion kenika ඕනේ තැනක තියෙනවා මේ නොරෙලියෙත් තියෙනවා, but this particular dandelion type of weed that is called rubber dandelion have a root. In the root, when you break the root, it will excrete cis 1,4 polyisoprene. This rubber dandelion is very readily growing in greenhouses in USA. So nowadays, what USA is trying is, they are trying to develop different methods to improve the harvest of rubber dandelion so that they don't need to import natural rubber from Hevea brasiliensis from countries like us. So this is one of a major threat to Sri Lanka when you talk about these substitute ones. The second one is gayule. That is again a weed, that is Parthenium argentatum. This also produces cis 1,4 polyisoprene. There are lactarious mushrooms. These lactarious mushrooms also produce cis 1,4 polyisoprene. So what happens if these plants could compete with the yield of Hevea brasilensis. What will happen to Sri Lanka? What will happen to Thailand? What will happen to Vietnam? They will not buy natural rubber or natural rubber based raw materials from Sri Lanka. We have a problem now. Understood? So this is gutta percha. As I said, the gutta percha is having trans isomer in place of cis isomer in Hevea brasilensis. So trans 1,4 polyisomer, you have the bulky group of here in the opposite side, in this side. So I'll take the attenuation. The two bulky groups situated in the opposite side of the double bond. So this is trans. So you have to know how to draw this one and how to distinguish which chemical structure is having higher mechanical properties. Now, in the case of gutta percha sap and natural rubber sap, you can see natural rubber sap or the Hevea brasilensis tree sap is completely cis isomer, and gutta percha, this is gutta percha. The gutta percha is having trans isomer. And here in natural rubber, you have more elastic. It's more elastic in nature, but in the case of gutta percha, it is more crystalline, so more brittle and less elastic than natural rubber. So we could tell that the chemical structure cis 1,4 polyisoprene is having outstanding properties, or the chemical structure of natural rubber is one of the major contributing factor for the outstanding mechanical properties that we need or we interested in manufacturing different items from. Right. So what is natural rubber? Again, I have talked about natural rubber over and over again. So one of you answer me. What is natural rubber now? Hasan, do you have power now?
It's milk.
It's milk.
White liquid
White liquid, yes.
that we obtain from
Rubber tree. What is rubber tree?
that we obtain from rubber tree.
Rubber tree is Hevea brasilensis. Okay, you have to remember the rubber tree means Hevea brasilensis. That is what I was talking before, right? See, Hevea brasilensis. So this one you have to, for example, for sure you should know this one. Hevea brasilensis. Okay, this is rubber tree. That is why I said why it is not only produced from Hevea brasilensis, but also from rubber dandelion, Parthenium argentatum, and also lactarius mushrooms. Okay, understood? Right. So natural rubber is the milky sap of rubber tree. That is again the scientific name of rubber trees, Hevia brasiliensis. It is in white color, as you said, and also it has a unique odor. Suandak tiyenawa neda, unique. And also it has a tack. What else do we have? What are the other properties that you know from natural rubber latex? Any more properties of natural rubber that you know? Latex, properties of latex. එහෙනම් මට තවත් homework එකක් වැඩි කරන්න වෙනවා. උත්තර දෙනවද homework එකක් වැඩි කරන්නද? Okay.
Madam,
Yeah.
you mean properties of the rubber
Natural rubber
latex?
latex. Steel latex. Yes.
Uh, it's a dispersion. Can
Yeah, it's a dispersion. Yes.
Soluble in water.
I couldn't hear you, Buddha.
Soluble in water.
Yeah. Now, do you know why this white color comes out? Is it due to a white color pigment? Have you ever thought why this rubber that is also latex, and in the case of milk that is also white, why do you think all these materials are white in color, and both these materials having that bluish hue also? Hue එකක් කියන එක දන්නවනේ නේද? අර ලස්සන ඇයි මේ සුදු පාට?
Because of the protein membrane.
No, I don't think so. No, it's not due to protein. What type of a system is this latex and milk? Latex is a colloidal system. Okay, both milk, the drinking milk that you take from cow and also from mammals, they are all colloidal dispersions. Okay, so all these colloidal systems mainly appear in white in color due to reflection or scattering of light inside the system. Now, what is this colloidal system means? Colloidal system means you have microparticles of immiscible rubber and protein dispersed in aqueous medium or water medium in very small particles. So this small particle size is the main reason why these systems will have white in color. In either case, it is not due to protein, but due to colloidal particle size. Usually in the natural rubber, this particle size is in the micrometer range. Maximum particle size is 1 micrometer. But in the case of normal colloidal systems, we consider colloidal systems as 100 nanometers. Other than that, most of the inorganic nanoparticles will have destability. But in the case of natural rubber, up to 1 micrometer, the latex is stable. So usually the particle size of natural rubber is coming out of as 500 nanometers to 1100 nanometers. That is 1.1 micrometers in diameter. So this fresh particles, fresh latex, you have a very spherical natural rubber particles dispersed in water and making it a stable colloidal system. Okay, once you centrifuge it, due to mechanical agitation, this spherical particles will usually change its shape to a pear shape. Pairs gediyaka හැඩයට වෙනකම් වෙනස් වෙනවා. But in the case of natural rubber, fresh field latex, the rubber particles are all spherical and dispersed evenly in the water medium. Okay, if the medium is based upon water, we call it aqueous medium. Okay, it is said aqueous medium if the medium is water. Okay. Now, as I said, when you talk about stable systems, okay, salt. Salt means sodium chloride dissolved in water. Is it a stable system where you see phase separation? Can you see any phase separation in sodium chloride solution?
No, madam.
What about sugar?
Same, madam, no phase separation.
Yes. But what happens if you add some oil into water?
Then there's a phase separation. Oil floats on the top. Water is in the.
Yeah. So
No.
that is the exact point that we need to talk about. In the case of sodium chloride and sugar, they both are hydrophilic. අහලා ඇති නේද hydrophilic කියන වචනේ? වතුරට කැමති hydrophilic. So when a particle dissolve in water, if the particle likes water, it will be a solution. If the particle that you are trying to mix does not like water, that is called as hydrophobic, then they will not tend to dissolve in one another or mix in one another. They tend to separate. Understood? That is why you have, when you try to dissolve oil in water, oil does not like water, so it tends to separate. Okay? Understood? So this is called hydrophilic, hydrophobic interaction. If the particle that you are trying to dissolve is hydrophilic, then it will make a solution. But if the particle is hydrophobic, then a layer separation will be observed. තේරුණාද? මම මේ කතා කරන්න යන්නේ ඊළඟ පොයින්ට් එක තමයි වැදගත්. ඒකයි මම අහන්නේ. තේරුණාද?
මැඩම් පැහැදිලි කරන්න පුළුවන් ද අපහු?
හයිඩ්‍රොෆිලික් කියන එකට සිංහල වචන කියන්නකෝ.
ජලකාමී.
හා. එතකොට හයිඩ්‍රොෆෝබික් කියන්නේ
ජල බීතික.
මට මතක නෑ සිංහල වචන දෙක. ඒකයි මම මේ ඇහුවේ. මට මතක නෑ මේ දෙක නෙමෙයිනේ මතක. ජල බීතික. පොඩ්ඩකින් බලන්න ට්‍රාන්ස්ලේට් එකවත් දාන්න. ජල බීතික කියලා තමයි තියෙන්නේ නේද මේකේ? ජලාකර්ෂණීය. hydrophilic කියන්නේ ජලාකර්ෂණීය. Anyway, if the molecule is polar, අයනයක් එහෙම නැත්නම් polar. polar කියන්නේ oxygen, nitrogen, sulfur වගේ ඉලෙක්ට්‍රෝන වලට කැමති අණු පරමාණුවක් තියෙන අණුවක්. ඒවා polarity එකක් තියෙනවා. එතකොට ඒ polarity එකකින් හින්දා ඒකේ තියෙනවා plus nature එකකුයි negative nature එකකුයි molecule එක ඇතුලේ. එහෙම ඒවා වතුරට දැම්මහම වතුරේ තියෙන ඔක්සිජනුයි හයිඩ්‍රජනුයි එක්ක interact වෙලා මේ charge nature එකක් හින්දා මේ දෙන්න වැඩිපුර එකට ඉඳ කැමති. ඒ වුණාට when it comes to organic substances, they don't have this type of oxygen, sulfur and nitrogen atoms, so that they are not polar enough to generate positive and negative charge separation within a molecule. So when you don't have this positive and negative charge separation, it does not like to interact with water where there is a charge separation. අපි මේ හැම වෙලේම කතා කරන හැම සිස්ටම් එකකම charge එකත් එක්ක තමයි කතා කරන්නේ. ඉලෙක්ට්‍රෝනයක් දෙන්න පුළුවන් එකක් වගේ එකක් තියෙනවා නම් හැම වෙලේම අර අයනයක් වතුරත් එක්ක interact වෙනවා වගේ නම් වගේ හොඳට interact වෙන්නේ නැහැ. දැන් sugar උනත් sugar වල මොනවද තියෙන්නේ? ඔක්සිජන් අණුවක් තියෙනවා. ඔක්සිජන් පරමාණුවක් තියෙනවා. ඒ හින්දා ඒක වතුරත් එක්ක interact කරලා හොඳට මිශ්‍ර වෙනවා. ඒ වුණාට තෙල් තනිකර කාබන් විතරයි තියෙන්නේ. කාබන් හයිඩ්‍රජන්. එතකොට මෙයා වතුරෙන් අයින් වෙනවා. එහෙම නේද? hydrophilic hydrophobic interactions මතක නැද්ද ඔයගොල්ලෝ O level වල science වලදී ලිව්වා? අර විද්‍යාත්මක පැහැදිලි කිරීම කියලා එක කරන්නේ. How many of you did your O levels in English medium? Can you put up your hands? මේකේ තියෙනවා නේද raise hand option එක. raise hand option එක තියෙනවා නේද? No. Anyway, so when you have total organic substance, they will tend to separate in layers. Now, in the case of natural rubber, it is again a non-polar molecule, but it is dispersed in water and making a stable system where liquid is always there if it is not degraded or deteriorated. So why do you think latex is a stable colloidal system? මොකක් හින්දාද වෙන්නේ? මේක කරනවානේ ඔයගොල්ලෝ අර preservation under preservation topic in raw rubber. You all do this one. How does this stability come?
මැඩම් මේ රබර් කියන්නේ කොලොයිඩ්ස් වලට තියෙන ඍණාරෝපිත ප්‍රෝටීන් ලේයර් එක හින්දා එතකොට ඒ වගේ ඒ ප්‍රෝටීන් ඍණාරෝපිත ලේයර්ස් තියෙන හින්දා රිපල්ෂන් එකක් අපිට බලා ගන්න පුළුවන් මේ මොලිකියුල්ස්
ඍණාරෝපිත එකක් තියෙනකොට වතුරේ මොනවද තියෙන්නේ? ධනාරෝපිත හයිඩ්‍රජන් ප්ලස් තියෙනවා. එතකොට වතුරේ තියෙන මේකත් එක්ක හොඳට මික්ස් වෙනවා. ඒක නැති වුණොත් layers දෙක separate වෙනවා. ඊට අමතරව තමයි ඔය ඍණාරෝපණ දෙකක් වල තියෙන විකර්ෂණය කතා කරන්නේ. Understood? So you have to talk about the natural rubber. It is, even though it is non-polar, it is covered with a protein layer. This protein layer is always existing as a negative charge layer, and this negative charge layer facilitates interaction between water so that it is dispersing. Second thing is the smaller particles all covered in negative charge. So when you have two like charges, these like charges always repel each other so that they will avoid getting contact. So that is two reasons are there. So that is, those two reasons are why that the latex is becoming a stable system. Okay, the latex is a stable system because of two reasons. Okay, so mainly natural rubber or rubber molecules are hydrophobic and it is dispersed in hydrophilic medium, which is mainly due to the non-rubber constituents present in latex. Okay. So what are the main non-rubber constituents present in latex? In solid natural rubber, you have around 94% of natural rubber and 6% of non-rubber constituents remaining. Okay. In latex, what is the rubber hydrocarbon percentage exist in field latex? කොච්චරක් තියෙනවද? DRC එක කීයද? That is what I'm talking, right?
25 to 35.
Yeah, mostly around 25 to 35. So what is the most common DRC? Around 30. Okay. Depending on the variety of the rubber plant, you can go less as 25%, and also that it can be go high as 35%, but most of the cases they are having around 30. Okay. Now in 6% of non-rubber constituents in dry bed, you have mainly proteins, phospholipids, and carbohydrates. What is the carbohydrate present? What is the main carbohydrate present? Pitchipitol. Okay, around 1% maximum. Okay, in the latex, you have, suppose you have 35% of rubber hydrocarbon, then you have around 1.5% of protein. You have around 1.5 carbohydrates, 1.3 lipids, and other organic solutes around 0.5, and inorganic substances around 0.5. Now, mainly these inorganic substances are the ones that will give rise to ash content. Okay, these minerals are the ones that gives rise to ash content. So this is the composition of rubber. Basically, if I ask you to write the composition, it should be in the latex. In fresh latex is this. And once it is processed to dry rubber, it is coming as this one. But mainly, if I have asked you to write the composition of latex, remember to write this part. Okay, so mainly this is varying with about 25% to 35%, and proteins and carbohydrates also will be having similar variations. Now, how do you separate these non-rubber constituents? Have you all done this one? Now, in the case of centrifugation, in a centrifuge tube, if you centrifuge natural rubber latex, you have zone 1, zone 2, and zone 3, and there is a watery region which is called as C0. Here you have the main rubber part. Okay, zone 1 is having higher rubber part. Okay, in the zone 3, you have lipids and carotenoids. If you want to remove carotenoids, you have to at least take the cream part out of here. Then you have C serum, mainly a watery part. You have liquid water-soluble proteins, amino acids, and other constituents in minor amount. You have a bottom fraction, again, that is white in color, similar appearance to rubber cream here, that contains proteins, minerals, and other ones. So once you take centrifuge latex, when you do experiments, remember, you should not touch this part and this part. Just separately take this part out. Okay. So when you centrifuge, you will see the latex in this way. So this is how you know the composition. So when you analyze each section, you can identify what is present. Okay, there are so many chemical identification methods that we will not discuss with you. That is not up to you. So we could analyze these regions and find different constituents in other experiments. So that way we have found rubber hydrocarbon, there are around 35%, protein around 1.5%, carbohydrates 1.5%, lipid 1.3%, organic solutes around 0.5%, and inorganic substances. Okay. So as Susanta sir did this one, right? The structure of the particle. Karanil, there are two structures proposed for natural rubber. The earlier one is the structure A. Okay, the earlier identified one was structure A, where you have rubber particles in the middle, which is covered by a layer of phospholipids. Likewise, you have NR here. Okay, this is the earlier one. Huh? Ayo. Okay. You have a natural rubber core, around which you have so this is the earlier version, that is structure number A. Okay, after at that time they thought hydrocarbon is inside, that is polar cis 1,4 polyisoprene is inside, Around it, you have phospholipid, and above phospholipid, you have proteins. But recently, it was found this is not the structure. Actually, this is the structure exists where proteins and phospholipids coexist on the cover of the natural rubber. So how do you draw it? You have natural rubber inside. Around this, you have phospholipids. Usually phospholipids have two tails like this. Green color ones are for proteins. They are coexisting on the natural rubber surface so that it will not come into contact with water. Only proteins will come in with the contact. So this is how the structure of natural rubber latex is. So this is how natural rubber latex structure is. So if I ask you to draw the natural rubber structure based upon the new findings from AFM technique, okay, this is AFM technique. Actually, do you want to know how was this derived? If you want, I will explain this one. Now, in previous times, there was no proper deproteinization techniques available. Many people thought use of proteolytic enzymes to be used and remove protein from natural rubber latex, but it was not success until recently. A deproteinization technique was discovered using urea, so that the urea will denature all these proteins and remove from the natural rubber structure. Okay, so once natural rubber, the proteins on the natural rubber structure is removed, they record a surface morphology. Surface එක බැලුවා atomic force microscope කියන technique එකේ. Okay, so in the case of atomic force microscope, this is the image. Okay, this one is the image for a natural rubber latex particle which is containing protein. So you can see this brown color covering the natural rubber. Okay, but when you closely see it, you can only see certain areas covered. After deproteinization, this is how it showed. So you could see most of this rubber this circle is uncovered from this dark brown hue. So this is how they found most of this particle is covered with protein, and there are certain areas you have phospholipids. So this uncovering whole area means your protein is mostly covered, your natural rubber particle is mostly covered from protein, and very small amount of phospholipids are present in places like this. See, only in certain places you could see small covering. So this comes to the conclusion that these two are actually not existing as two different shells, but a single shell where certain areas are covered with proteins and certain areas are covered with phospholipids, so that altogether this sphere is covered from a single layer with different regions of phospholipids and proteins. So this is how they learn, they means the scientists learn this is the correct structure, but this one was the older one. This is the newly accepted one, and this is the old one without evidence. So in many cases, you could see still this structure is being used, but actually nowadays we have to use this one as the proper structure of natural rubber. In any way, you could see that proteins are in the surface, and these proteins are negative charge, so that this polyisoprene core is completely covered with either phospholipids or proteins, and it will not interact with water. Only the ones interacting are polar heads of the phospholipid and proteins, so that it will have a good interaction with aqueous medium, giving it a better stability. And also, it is important to know that phospholipids again cover here. So still, when the protein is removed, you have still certain amount of stability remaining in the latex. Okay, so nowadays, many industries ask us to talk about this deproteinization methods. We will talk about it later, but still there is some degree of stability because of this phospholipid layer on the natural rubber. But anyway, that is not so big as protein, so that we need extra stabilization for natural rubber when once you deproteinize it. So we'll learn these things in future lessons. So basically the introduction part is this much. We will move to proper lectures from next day, but I think we could do the lectures even tomorrow. We could start the proper lecture from tomorrow if you are okay. In the evening, 4 o'clock to 6 o'clock, I think it is going to be power cut again. So shall we do it in the 1 hour in the night? Pasindu? Shall we do the lecture from 6 to 7? if the power is available, we can do 6 to 7. Or Thursday, do you have any free time? Thursday also. So we will move to the proper lecture from next week. Oh, so මේගොල්ලෝ නිතිද?